My name is Oscar. I'm one of the co-founders of Mystic AI. And at Mystic, we basically built the infrastructure for people to be able to deploy machine learning model without them really needing to have either an engineering team or themselves being engineers. So we wanted to make sure that data scientists and ML practitioners were able to independently deploy reliable ML at scale on any infrastructure without them having to understand each of the nitty-gritties of each of the cloud providers and all the DevOps engineering that comes with it. I guess like a bit of our title is really the modular backend for your AI deployments. The reason why it's modular is because we wanted to bring you the freedom of using any tool that you want. We didn't want to limit the data scientists with any of the packages that they like to use, whether it is for monitoring, whether it is for keeping track of some of the models. Mystic, what brings to you is really all that DevOps infrastructure of how do you go from this open source model or your own model to the scalable endpoint. So the one of the things that we've seen is that no matter in which industry you're in, you're going to need to think about how do you build reliable and scalable and high performance infrastructure. Even if you are on the generative AI, as we are seeing so many startups at the moment, that they're trying to leverage some of the biggest open source LLMs or also the closed source. But when they're thinking about like deploying their own fine-tuned variants or this kind of their own custom models, then they need to think about what's next, what's the infrastructure required, and all the way down to pharma and more traditional companies in which they've been leveraging ML and large models for quite a long time. So when you think about what it comes with deploying this type of ML models at scale, there's, depending on your industry, depending on your objective, there's many things that you need to consider. What happens when you have not just one model, but many of these models in production? Each model may have its own different requirements. So you need to consider that when you're trying to package this model. You need to be able to understand where your data is and make sure that this deployment is as close as possible to what the data is. So you need to integrate it with whether it's a specific cloud provider or it's on-prem. Maybe you have hybrid infrastructure where like you have quite a big data center in your own offices and your own like company, but then you also want to scale to other cloud providers should they require more compute. You also need to make sure that because you're running on such expensive hardware, you need to make sure that you're able to optimize all of this from the get-go. And so what we've seen is that many engineers spend quite a long time really trying to figure out how to make the most out of like cost optimizations and other optimizations that really bring down the cost of running these models at scale. When that happens, you are looking at like talent and engineers that are really well suited for this type of task, that they've done this before, and it's quite a like scarce engineering talent to actually hire for. So that's another challenge if you're like trying to build your own ML platform. Obviously, because you're handling so much data, you want to make sure that all of this data is well stored and well secured in your own cloud provider or whichever is the place where you're running these models. And also depending on your privacy terms, depending on the country that you're in, you're going to have different regulations. So you want to make sure that from the beginning, you're also following the right regulations. And definitely like we're in an industry where everything is changing so rapidly. So we need software that is able to evolve into all the requirements. So now we're seeing a much higher utilization of these larger models, which require multiple GPUs at the same time, require a lot of memory to run certain of these models. When traditionally there was some more classical models that we were able to just run it on CPU. But as we see the industry getting more towards bigger and faster models, then we need to make sure that the infrastructure is also optimized for it. And so what we've built at Mystic is kind of like the backend for all of these type of ML deployments. Because we know that data scientist works on Python, we made a simple Python library to abstract all the rest of the infrastructure that comes after once you've built this model and you have the right weights and you have the right pre-processing functions, the inference pass and the post-processing functions. This is what we call the pipeline. And so what happens next is really the backend of the DevOps engineer or the software engineer that has built that infrastructure for you, whether it is attached to a specific cloud provider or it is your own internal ML platform. And so we had certain goals that we needed to hit according to our customer feedback. We wanted to make sure that it was able to be deployable anywhere. It was able to optimize all the cost and performance out of the box. We have the end user, the data scientist, or the company itself to have to go through all of these optimizations themselves and have a team of engineers managing it. Extremely low latency. So we're seeing our software run under 30 milliseconds at scale for all of these deployments, which is quite ahead of a lot of competitors. And then obviously making sure that it hits the compliance and security on top of being able to monitor how all these deployments are doing. And so the way it works, our software, it's very simply, it's very easy. The data scientist just needs to package their ML pipeline. Let me show you exactly what I mean by packaging. So here I can show you on my code a pipeline that I've just built, which is basically Llama 2, and it's actually streaming Llama 2. And so let me show you exactly what's going on here. So if we run this streaming Llama, this is now running a streaming of I sent a request of summarize the following text in 5 lines, and I sent a copy paste of Wikipedia of who was Plato, one of the philosophers. And all I had to do was really call the right model, which I had deployed previously, and then just call the generator, and I was able to see here in real time the streaming of this model, which is deployed on our software. Now, this is the end customer is seeing this is how to interact with this deployed model. But what I wanted to show you is how easy it is to package your model. So in this case, I built this in a object-oriented fashion, but you can also build it in a functional way or object-oriented, whatever suits you best. But the main thing here is I'm using also Hugging Face to run the underlying inference of the model. So I'm loading the weights from Hugging Face, I'm loading the tokenizer from Hugging Face, and then I just define the Python code that loads this model. So here I'm just loading into memory. Then I define the streaming inference, which is just a separate thread to just get the tokens as it processes, and then yielding that text back to the output. And so here, if we look at here what it is, it's all Python that you would be running locally as normal. But the only thing we've added is these decorators, which allow us to understand, okay, these are functions that you want to be called on your endpoint. Now, the definition of the endpoint, what we call the pipeline itself, we have the pipeline graph builder, which is this context manager here. So in here, you define the inputs, what happens with those inputs, and then send the outputs back to the end user. So you can think of what's going on here is just the endpoint itself, which in this case, we're calling this model that we had defined here. So we're initiating the object Llama pipeline, which we've already decorated, so we can call it properly in this context manager. We're loading the model, so we're then calling this function here, and then we're loading as usual as you would do with Hugging Face to load a model from the repository. And then we just run the inference, calling this other method of inference, in which case we're just passing the inputs that have been defined on the pipeline, so the prompt and the keyword arguments, which is here. So I'm passing a list and a dictionary, and then I'm taking that dictionary and passing it into the stream inference function, which is defined in here. So I can, obviously, because it's Python, it's customizable. You can run whatever you want in the Python element. And then that's it. This is really the definition of the endpoint. I build this pipeline and then I upload it. On upload, I've also defined the environment that it needs to run behind the scenes, which our software, I'll talk about later, how this is managed by our software. But then I upload the pipeline. I define which is the pipeline that I want to upload. I define the name of the pipeline, what I'm uploading, that I want it to have. We have a tag system, so a versioning system in which you're able to just upload different variants of a pipeline. So you can see which is the latest one, and it keeps track of every single time you've updated a pipeline. So there's this pipeline versioning that definitely has been one of the features that a lot of people wanted. You say, okay, I want to run this pipeline with this environment. You can also define how many cached models do you want across the scalable cluster. So from here, you can say, hey, I always want one pipeline, which is this model that I'm running here one pipeline to always be cached on one of the GPUs. So you can define it here. Also, to get the most out of the scheduler, you can also define a specific amount of memory that is required to run this model. So the cluster will make sure to spin up the right GPU for this type of pipeline. And here we need at least 40 gigabytes of VRAM to run this pipeline. And you can also define the specific accelerator that you want to run this on. So in this case, this is running on A100 80 gigabytes, but you could run on other pipelines if this was to be loaded into 8-bit or 4-bit, etc. The beauty of this on the modeler side is that you could do anything inside this, right? Because it's Python, you can import custom backends, you can import your own VLLM implementation if you wanted. So some of our users are using VLLM as a backend to run this type of pipeline, so you get more tokens per second. And so there's a lot of optimizations that you can do yourself, and because it's Python, it integrates with all of this. Where Mystic comes in is packaging all of this with a simple few decorators that you've seen. There's one here, another one here, and then you build a graph defining the inputs, the forward pass or whatever you want inside, and then the outputs. And then that's it. Then you upload it and you define the environment that you want to be attached with it. And then on the end client, when you've uploaded this pipeline, then it's as easy as a few lines of code to reference the right pipeline that you've uploaded. And then you pass whatever is the input that you want, and the model will process it for you. So going back into exactly what this software does. So we've seen how to package this. The deployment is as simply as uploading with one line of code of Python. Then all of these clusters that get monitored, get deployed for our customers, our customers get like a Grafana dashboard where they can see all the metrics of these deployments that is going on. So they can understand. They can also hook into our Prometheus database that is attached with all of these deployments, so they can themselves create their own type of like panels and dashboards. But really, the software is giving you all of these out of the box, where you can also monitor this type of deployments. And then you can just keep on repeating for any pipeline that you want to deploy. Our software will make sure to provision the right GPUs, downscale, upscale, etc., as per your requirements. So going through a bit of like some of the out of the box features that we really have solved with this. We've been able to run this on multiple clouds. So we wanted to make sure that this is something that our customers can take to AWS, GCP, on-prem, or having a hybrid type of setup. We've able to run all of this infrastructure, all of this API with less than 30 milliseconds of latency. So you can chain multiple pipelines. You can run pipelines at a real-time fashion. And there's no very minimal amount of overhead really added by using our software. There is a huge high scaling capabilities. So we've also been tested this with some of the customers, which they've scaled to hundreds of GPUs immediately, and our software takes care of doing all of that. On that cluster, some of our customers wanted mixed GPU types, so we were able to just run on the same cluster multiple types of GPUs, because as we said, some models require bigger GPUs, while other models can run on smaller GPUs. And so our software makes sure to spin up the right GPU for that model. As well as you're able to, if you're familiar with CI/CD integrations, you can make all of this integrate with your own favorite CI/CD, GitHub Actions, etc. So you can just upload a new pipeline every time one of your engineers updates the specific repository, etc. Monitoring and alerting, you can also integrate this with not only the out-of-the-box monitoring system that we have, but we also can send you alerts to your favorite place. So, for instance, we use Slack integrations quite a lot, so you can just receive a notification if something fails or something is not looking good. All of these metrics are kept track on the Prometheus, so you can actually just feed that into one of the alerts. Obviously, all of this is running on your own VPC, on your own cloud provider. So there's maximum compliance by running it on your own private cloud. As well as some of these models require multiple GPUs in order to run the inference. So this out of the box supports talking to multi-GPUs as part of the inference definition on the pipeline that I've shown you. You can also run models not only on GPUs, as I focus on this presentation, but you can also run it on CPUs. So anything like XGBoost, Fashion, etc., like models are like smaller or models that can just run very well on CPU, our software will take care of just scaling to thousands of threads if it needs to in order to process that parallelly. So this is, at the end of the day, is a parallel type of workload manager that you can just run whatever you want, either on CPU or on GPU. One of the features that we're really happy and proud is our run multiple models under the same GPU. So this is what we call the many models on single GPU. When one of our customers really needed to manage hundreds of models on the same GPU, because there's some models that have a high utilization, but other models don't have that much of a utilization. And they wanted to make sure that they didn't have just one GPU per model. And so our custom multi-model GPU handler makes sure that multiple models can speak to the same GPU. And so if that model is not being utilized for whatever reason, then the other model can access that same GPU. So you are utilizing only one GPU at a time for many models that are deployed. And so that becomes very, very useful for handling spike loads or like sporadic usage of some of the models that we've seen as well, some of our customers. As well as, we've mentioned some of the cost optimizations that we needed to make sure we were able to support. So we are able to support out of the box spot instances, which is already almost 1/4 of the price reduction over just standard like deployments on GPUs. And so that's another feature that you don't have to manage. So out of the box, you get extremely cost optimizations without you having to manage all of that yourselves. And more about the architecture side of things, of like some of the features that we've had to build almost from scratch in order to make sure that we were able to really optimize this ML platform for our customers. At the end of the day, we're seeing that every single company that wants to deploy ML has three main routes. Either they build their own Docker plus Kubernetes platform, which is the traditional method that we've seen many companies approach it, because they're just used to using Docker, packaging their models on Docker, and then running on K8s. The other one is you go to a specific cloud provider, say Google, say AWS, say Azure, and you go to the specific cloud vendor solution for deploying models. But obviously that has cloud lock-in vendor, as well as, maybe you just want to move all your data from one cloud provider to another one because it has some features that you prefer, or you just need more GPUs and you want to have it like accessible across multiple GPUs. Or if you're in the finance vertical, you need to make sure that you're able to deploy things multi-region from the get-go. So there's certain implications when you deploy models for regulation purposes or for engineering purposes that you need to make sure that you're able to access multiple clouds, or you just don't even want to manage that cloud provider. That's where it comes the third option. The third option is about the optimized ML platform, the ultimate kind of optimized ML platform, so you don't have to build it yourself. We've seen people go through the Docker Kubernetes approach, and they run through the challenges of doing that when Kubernetes has not built really for GPU type of workloads. And one of the challenges, as I mentioned before, is about how do you cache models ahead of time, for instance, or how do you put as many models on the same GPU, all of that while running on Docker on K8s. That's something that is very difficult to do. And so we've built this platform so you don't even have to manage all of this. And so we've built our own custom software to make sure that it's handling all of this properly, so you don't have to. So this is the third option, right? The third option is to come, to Mystic, and then our ML platform handles all of these deployments for you. So some of the architectural redesigns that we've done is, for instance, our own custom routing. You need to make sure that you're able to optimize for how long a specific pipeline takes to be performed, and that's part of the metrics that we keep track of. So we're able to optimize the right GPU and the right timing of provisioning that GPU when we know how long a specific pipeline takes to run and when that pipeline is going to be running, etc. So there's a lot of intelligence going on in our scheduling and our routing. On the autoscaling side, we have our own dynamic autoscaling, which basically just takes care of upscaling, downscaling as many GPUs as you need, depending on usage, depending on how many requests this endpoint that I showed. So like the model that I was showing earlier, the Llama 2 on streaming, depending on how many users are like calling this streaming endpoint at the same time, you're going to need different GPUs to run this. So this takes care of requesting those GPUs even ahead of time if there's enough data about it, depending on the usage and predictability of your ML deployments. And so it all takes care with our own dynamic scaling. Then there's the preemptive caching, which helps us with the call star optimizations. So we have several metrics that allows us to understand how can we make sure that the call star and the latency given by how long it takes this model to get stored on the GPU, as well as the input that you want to feed into this model. That is what we call the call start. How can we minimize that? And so there's several things that we've made ourselves to make sure that we can minimize this as much as possible. And so the end user doesn't keep hanging there until the model has been cached on the right GPU, because we're able to cache these models before even the request gets processed. And then one very important one, it's, as I mentioned, every pipeline has different packages. Every model has different requirements. So we've built our software with our own environment management, which allows you to really upload as many pipelines as you want with different environments. And our software will take care of caching the right environments on the right GPU for the right pipeline and being able to run all of these models on the same GPU and maximize utilization of this GPU. So all of these features really help you make your deployments extremely fast, make your deployments extremely cost effective, because you're leveraging things like spot instances, things like GPU sharing, fractionalization, and so on, and also intelligent routing. So there's features that allow you to reduce the cost, features of performance. So we built this to be extremely fast compared to other platforms out there. And we've made sure that all of this is scalable. So because it's a production environment, this platform is for deployment of ML. We need to make sure that our software runs very well. At the end of the day, this is in front of your own customer, your end customers. So our software is built for robustness. So some examples, for instance, Charisma, thanks to our software, they were able to run 3 times faster than using AWS services on their own. These guys were using our software for kind of like chatbot applications inside games and inside other media content. And so by using our software, they're able to just go way faster than they had done before by building their own kind of like ML platform on the specific cloud provider. Another customer, Dummy, so they saw a 75% cloud bill reduction, and they needed from day one a scale to hundreds of GPUs, because that was like the blocker for like onboarding new customers. So with our software, they managed to like onboard a lot more customers very quickly, and so far very happy users. And a bit about us, we started back in 2019, initially working on hardware. We were making our own FPGAs for machine learning. And since then, we've pivoted towards more the software element. We've always believed that the infrastructure is more of a software game. And so since 2020, we've been really building software to abstract the difficulties of running machine learning on the infrastructure of our customers. And we've managed to build products like serverless GPU API, which is actually we're going to be releasing, by the time of this talk, we're releasing next week, early September, like the new API serverless GPUs. So some of our customers are going to be able to leverage this backend for our own cluster of GPUs, which is a pay as you go. But then if you really want the performance, you really want all of this to run on your own cluster, on your own cloud provider, that is where the full software solution that I've been talking about right now can really be extremely useful. So there's a lot of things that we're releasing. There's a lot of engineering behind the scenes to build this, and we've been doing this for quite a long time. And yeah, so that's basically me. So definitely feel free to reach out if you guys are interested on a full demo. My email is or@mystic.ai, and I'll be super happy to help you.